This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime podcast. This is episode 64, and we have a great guest today. Rosemary Barnes is joining us on the show. She is a consultant with Pardalote, and she also runs the YouTube channel Engineering with Rosie, where she educates the public on all sorts of topics in wind energy, on wind turbine design, on blade aerodynamics, lots of really interesting stuff, tons of new videos on green hydrogen. So we wanted to have Rosie on the show to share her expertise. And let me run down a little bit of her background. So she has her Ph.D. in structural design and composite materials from the University of New South Wales, Canberra campus in Australia. She worked for LM Wind Power as an engineer, and she just has a lot of experience in a lot of different areas in the wind industry and as an engineer. So, Alan, what were some of your takeaways from our talk with Rosie?
Well, I just like the way she thinks. She thinks in terms of systems, not in terms of components. And I think that's for an engineer is a good way to think about bigger problems. And if you've watched some of her YouTube videos, she talks about different parts of what I'll call the renewable energy or green energy economy and how that can function and whether we can do the things that are being promoted by, in some cases, politicians, and whether that really can come to reality. And when you start looking as a whole system of components, green hydrogen or tidal power or vertical wind turbines, there's a lot more to it than you would think. And so the normal person who's not an engineer would think about. And she's an engineer, and she's been around it quite a while, and so she can connect the dots for you. And that's extremely helpful to make it more realized. Is it realizable or is it not? Or what are the real costs in doing this? And it may not be just in the component themselves, like a vertical wind turbine. It may be all the other things. Like how much does it operate? Is it efficient? Can you scale it up? All those different aspects. And that's what makes her approach and particularly her YouTube videos very interesting.
Yeah, so we covered a bunch of topics in the show today. We talked about vertical versus horizontal axis wind turbines, talk about blade design. We talk about blade heating because that was one of her specialties, one of her projects with LM Wind Power. Bureaucracy in some of these wind energy companies and just big business in general. Like Alan, you've been subject to it. She's been subject to it. We also talk about energy transitions. That's a big passion of hers, is helping companies find the right tech and do their due diligence to help with making transitions from one energy source to another. So as I mentioned, she has her own company called Pardalote. She does consulting, helps companies with energy transitions, with due diligence, with engineering and wind turbine related projects. And then we're obviously going to put links to her company, her show, or her YouTube channel, all that stuff. But without further ado, we're going to jump to our conversation with Rosemary Barnes, engineer and consultant with Pardalote. All right. Well, Rosemary, thank you so much for joining us. And hello from the U.S. This is our second guest in a row from Australia. So how are you doing?
I'm doing well, thanks. And yeah, thanks a lot for having me and staying up late to meet our morning.
Yeah, the time zone thing is crazy. It's obviously, it's 6 o'clock here in the US and it's 8 o'clock there in Australia. But yeah, we're happy to be here with Engineering with Rosie. So let's get started. So you're a structural engineer, and following your Ph.D. in composite materials and structural design, you went to work for LM Wind Power, which was one of the really interesting things that we wanted to kind of pick your brain about here today. So let's talk a little bit about your time at LM in a bit. But first, wind turbine blades have changed a lot. And one of the things you do really well is educate people on YouTube. And so tell us a little bit about how you got your engineering channel going. You're now, you've surpassed 20,000 subscribers in your first year, which is awesome. And you talk a lot about green hydrogen, vertical axis versus horizontal. So tell us a little bit about, the educational work you're doing out there for the masses.
Yeah. Okay. So my YouTube story is a bit of a cliche. I think it's one of those lockdown projects I found myself in between jobs at a weird time. So I had some time on my hands, and it all started with, I was living in Jutland, the peninsula in the west of Denmark, and they've had wind power there for, that's like where they got their first electricity actually, from wind turbines back, over 100 years ago. And then from the 70s onwards, they have been developing wind, and they never stopped. So when you're kind of driving around there in Jutland, you can see the evolution, all the different crazy designs that people tried out before they all kind of converged on this three-bladed upwind design. So I just had an idea for that one video to talk about the different designs and why the evolution went the way it did. And then I just enjoyed it, and I got more and more ideas from videos the longer I was doing it. And viewers, they comment, they tell you, I've always wondered this, or can you make a video on that? So that's how the vertical axis videos happened, because one particular viewer kept on asking for it, and I didn't know much about it. I mean, most people working in the industry are purely working on horizontal axis turbines and don't take the vertical axis very seriously. So I looked into it, found I couldn't find a good explanation of how the aerodynamics worked. Like I couldn't get it clear in my brain, So I kind of just sketched out some vectors and figured it out, and thought that I would share it. And I think that's how a lot of my videos work. It starts with me having a question: why is this done like this? Or, how is this going to change in the future? And then as I learn about it, I share that same process with the viewers.
Well, and I think that's one of the things that has made YouTube so endearing and made it so huge, is that there's a lot of curiosity channels out there, right? And there's some that have been around for 10, 15 years. And then there's a lot of new ones who people are just trying to answer questions that they have in their own lives. Just these, why does this work? How does this work? I'm going to just do a deep dive on. I watched a video about why McDonald's ice cream machines are always broken, which was actually a fascinating video. There's like a conspiracy behind it. It's really actually super interesting. So I think that and your channel is becoming more and more relevant now that wind power is taking off. So people, this stuff's in the news. Everyone's thinking about it, especially here in the US. And, I want to stick with the vertical axis stuff, because even now there's new news about vertical axis wind turbines. It's like, is this the future again? And it seems like every 5 or 10 years, someone's asking, are these the future? But yet they never seem to be. I mean, what is your official take on the vertical axis versus horizontal debate?
So I think that they can get better. They should be able to get more efficient, but they have this, really common engineering trade-off between efficiency and complexity. And at the moment, no one has been able to make a turbine that is efficient without making it so complex that it doesn't last very long.
Yeah.
And you do need to note that no one has made a vertical axis wind turbine yet that's making cheaper electricity than horizontal. They haven't even got remotely close. I think that's what a lot of people miss. But I do think that there are certain advantages to that design that will fit certain specific niches. So those niches would be like distributed energy, and especially like microgrids where you might not have like a lot of solar, or not at all times of the year. Places where noise is a real problem. So there, I think that we'll see them, but I'm like really sure that it's never going to replace horizontal axis wind turbines. It's going to fill in something that the horizontal axis turbines can't do. Yeah, and I think it's also related to the question of urban wind in general, which, yeah, it's an interesting topic because people want to see green energy being made. So that means they want to, you know, see it near their homes, near their workplaces. But the fact is that the quality of the wind really, it matters so much with, with wind energy. You know, the power in the wind, it's related to the cube of the wind speed. So you have twice the wind speed, but 8 times as much power. So that's why we see the big utility scale ones are getting taller and taller, and they're moving offshore despite the challenges because the wind is so much better there. So you can put a really efficient turbine in an urban area, and it only has such a small potential of what it could capture because the wind speed's low. So it's a real natural limit on how much that can do. And I think that's disappointing to a lot of people because people really, you know, they really love these small turbines, and I get that as well. Like, they're exciting for engineering challenge, but yeah, I don't think that it's going to be. It's not going to replace anything. Yeah, it might be the next thing, but it's not going to be the only thing ever.
Well, and do you feel like it's one of those things where, especially again, people who have an engineering mind or engineers themselves feel like, hey, this is an untapped, like, I could be the person that designs the next vertical axis that hits it big. Like, they feel like, I mean, what are you going to do if you're sitting in your home with horizontal, right? GE has a 13 megawatt behemoth. So does Siemens Gamesa. So does Wet Vestas, right? No one sitting in their home is going to outdo them. But do you feel like that's part of the driver, that it still gives people this sort of this hope that they could be a part of that revolution and spark it through their own sort of homebrew engineering?
Yeah, I think so. And I mean, I get a lot of, like, every week at least, someone will tell me they've got a new, more efficient vertical axis wind turbine design and want to send me their AutoCAD files, which is really cool. And I mean, I hope that they're going to continue to develop them as well, because that's, yeah, I mean, it develops good engineering skills. You learn what the constraints are when you do it yourself. Like, I had this video on my site. I made a gingerbread wind turbine, just, you know, for an end of year project. And I mean, I have an education in engineering and in wind energy, but I learned so much, especially about how important the wind resource is, because by far the most important factor for that project was how windy it was going to be on the test day, and finding the best site, you know, I would see where the wind was coming from and find the bit of the beach that was, you know, angled that way. That was by far the most important thing. I could put nearly any shape of gingerbread blade on there, and if the wind was strong enough, it would work, you know. So yeah, I mean, you learn a lot by doing so. I'm really excited that the vertical axis and even small horizontal axis, you know, these are the scale that people can get their hands dirty, and that's, you know, that's fun.
Well, and this kind of speaks to some of the other, you've mentioned in a number of your videos that, you know, there's the practical and then there's the theoretical, where I feel like a lot of those ideas seem to live only in the theoretical. And Al and I have talked about this on our companion podcast on aerospace engineering. Right now, there's a huge boom of new electric vertical takeoff and landing vehicle designs. There's a new one seemingly every week from some company. They're like, hey, we're going to take 100,000 people in an eVTOL now. And then we're going to do, it's just like a crazy new thing. And it's like, that seems like it's
in one.
Well,
there's one thing, like airplane that will sit 100 people in.
Yeah, I was exaggerating, but the challenge is these companies who are at the forefront are trying to get like 2 people or 4 people to make, you know, the lift ratios work and all that stuff. And just the other day we saw a company said we're going to do 40. It's like, okay. I mean, do you feel like there's a lot of this in engineering where it's the practical sometimes lags behind, or maybe not lags behind, but I mean, how do these theoretical models end up fleshing out? Is it just sort of natural selection over time and it comes down to numbers? It's
kind of complicated. I think maybe wave energy is a really good example for this, because it kind of, it's something really complicated, but I think it started a bit too late to ever really get there. Because you compare it to like the internal combustion engine, right? That is a super complicated thing, like so complicated. If you had an electric motor first and then someone was like, hey, look at this internal combustion engine, you'd be like, are you kidding me? Look at that, all those parts, you've got explosions inside there. Like, are you serious? Like,
it's true.
But it got there because it was by far the best thing at the time, and people copped it. But wave energy, we have other alternatives. Whereas so like wind started out so simple, thousands of years ago. Even people were figuring out how to put sails and rotate something from the wind to make a energy or power in a form that you can use it, and it just gradually evolved, took off a lot around the turn of the previous century, and then again in the 70s with the oil crisis. There was like a little bit more interest in making it work for electricity. And it had time. They started off very small. They were really small back then. 100 kilowatts was
it was a lot.
Yeah,
it was an industrial kind of that was a big thing. Yeah, and then they gradually got bigger, and they figured things out, and they gradually got more complicated. At first, they were fixed speed. They weren't changing the speed to change with the wind speed, so they were missing a lot of the energy that they could have captured. They were operating below their maximum efficiency most of the time. Then they, got variable speed. Then they could change the pitch of the blades, and there's all sorts of tiny little improvements that have happened since then. I mean, now it's gotten to the point where you can get an extra 0.25% energy over a year. Then everyone's like, oh my God, wow, this is a huge innovation.
Sure.
And not to mention going to better wind resources. So we're going into cold climates, even though you have to heat the blades, which is a pain. We're going taller, even though, obviously it's really hard to make a very long, skinny tower, but it's worth it for the wind. Same with offshore. But it all happened incrementally, and it was very reliable before they kind of moved to the next stage. But then something like wave energy or vertical axis turbines even, I think it can be really tempting to say, oh, okay, so wave energy, out in the middle of the ocean, there's these huge waves in storms. We've got to be able to capture all that, and you kind of go straight out there. And what happens? You build a really expensive prototype, it gets destroyed, the company's finished, and then the next company comes along and tries it. So it's you're making the job a lot harder for yourself if you have to make those big increments. And I think that's the risk that, especially like a backyard engineer or a home engineer, you have the great idea. You say, there's this wasted wind resource along the side of roads or on roofs or whatever, but until you actually make it, you don't realize all the tiny complicated details that are going to get in your way, because it doesn't just have to be efficient, it has to last a long time, otherwise it's going to be very expensive.
Well, and that's a great I think point to transition here. I know Alan has a ton of questions about your time with LM, as do I, because working for a company like that where you're making these enormous blades out of high-tech materials, which is obviously your expertise, with your PhD in composite materials. I mean, how have those blades started to evolve? I mean, you've seen them over your career, but like you said, all those little tests and retests and what's failed and what's worked. Can you kind of take us through just like a little flyby of the design process? And obviously we know there's confidentiality, all that stuff, but what is it like working for a big blade manufacturer like LM?
I moved to a big company like LM on purpose. Before that, before I went back to uni and did my PhD, I had been working with a lot of startups, not just wind, also some alternative solar and a few other things. And that's really fun and exciting, but a lot of those companies, it's like so few of them make it to the point where they're actually making green energy. And I felt like, okay, I really want to go to a big company, and wind is so mainstream, it really, it really works as it makes a good return on investment. You don't have to be a greenie to want to invest in wind energy. You just have to like money. So I really wanted to be part of that, something that was actually making green energy and that, would have been fossil fuel otherwise. And I also wanted to learn those, like the things that big manufacturers do, because they're not just making one product one time. It has to be consistent every time, cheap and consistently high quality. And if it's not, then it costs them a lot of money. So I really wanted to learn how that huge system works with the quality and the manufacturing controls, and even starts right at sourcing, making sure that your suppliers are delivering consistent quality. That was something that I definitely experienced. I mean, LM has, I can't even keep track of how many factories, but definitely more than 10, maybe even close to 20 now, all around the world. So I learned a lot.
So moving from a smaller company to a larger company, what are the differences in the engineering styles that you saw between those two? One, it has limited resources, obviously, and you're trying to be as efficient as you can. The other one has almost unimaginable resources. What does that mean to you as an engineer as you move between those two?
The quick answer is bureaucracy. And that is definitely a double-edged sword. If you say to someone who works in a startup, bureaucracy, then they probably think, oh my God, this is a nightmare. I would never work somewhere like that. But on the other hand, for manufacturing especially, the bureaucracy is really like a safety net for you, or like a comforting blanket as well, because you have the instructions that every worker, every factory around the world is following the same process instruction to make things in the same way. They're doing the same quality checks, and you need that. I have tried with my projects to bring in more and more agile methods, moving fast and reducing documentation. You just simply can't have major manufacturing without a lot of documentation. You wouldn't want to try. I mean, imagine you find out that there was a problem with some of the fiberglass that you're using in your blades. That means that these blades have to be repaired, and you don't know which blades they're in. You need to know exactly what's going on in every blade and be able to trace back when you find a problem.
Well, I think that's a good point, because when you hear the word bureaucracy, it almost has an exclusively negative connotation. No one ever talks about bureaucracy in a positive light, but really what you're talking about is checklists, right? I mean, these are all the things and the procedures that have been passed down. Hey, these work. We need to make sure we follow them, and it's quality control and all that stuff. And I think that's interesting, where it's really rare that you hear the positive side of bureaucracy. Really, all you think about is just like people stamping things and telling you to go back and get your 11 bosses to approve it.
Yeah.
But in reality, that's how these big companies, pump out, like you said, high quality products at, a cost-effective price. But
that said, it never feels like a positive when you're working in that system. You're never like, bureaucracy. You're like, oh my God, can I seriously not just buy these bolts that I need because it's not from an approved supplier? There are definitely all of those commonly known weaknesses.
Well, it's not the bureaucracy that you think of in terms of just management. I think you hit the nail on the head where it's like purchasing. It's all the little things. Like I do need to buy some bolts. Why does it take 8 weeks to get a couple of bolts I could get at the hardware store for this little project I'm working on? It's not just layers of management. It goes sideways also. It's hard to describe unless you're in that environment. Did you see much of that? And how does a wind turbine company that's making these gigantic projects increase incrementally with all that organization around it all the time, and they have to keep up with the competitors? How are they doing that internally to keep moving to larger and larger blades? How is that possible?
Yeah, so that's a really interesting point, and I think that one thing you got to note is the wind turbine industry is at a bit of an inflection now. So I think that the bureaucracy needs to probably adapt to that in a lot of cases. So, in the past, wind turbine blades are very similar to the one you made last year or the year before that. It's, you have a blade. It's basically usually two webs, 1, 2, or 3 webs, depending on the manufacturer and the length of the blade, and fiberglass shell. And that was it. And so, 1 year you're making a 12-meter blade, and then the next year it's 13, and then it's 15, and, all the way up to 60 meters. That's pretty much what it was. Approximately 60 meters. And then recently it's changed, and now we're seeing bigger changes. You see companies bringing in carbon fiber, which sounds so straightforward, but it's not at all straightforward. That was a massive change. Trying to automate some parts of the process, or just have some pre-made parts, and then you see the really big technology changes, like the 2-piece blade, or, like the longest blade in the world went from 80-something meters to 108 meters in one go. And, huge changes. And you can't, in the past, you knew that your slightly longer glass blade was going to work basically the same as the previous one. So you could follow the exact same process and be sure of a good result, and that was the right way to make a high quality product. But now, when it's totally different, you can't work like that. You can't just say, okay, we're going to make a 2-piece blade and then just make 1,000 of them and install them on wind turbines and think everything's going to be fine. You have to do some testing to find out what you don't know. You guess beforehand what's going to be the challenges with this, and you test for it. But when it's really new, you don't know exactly how things are going to fail or where things are going to go wrong. So you do need to have some increments in there that the industry isn't used to. And it also is really hard to fit into the normal product development time frame. So all of these really big technology changes, super exciting for engineers working on them. And also it's causing a big change to the industry.
Are they handling that in the aerospace world? Let me give you the example in the aerospace world. So how we handled on aircraft was we had this little secret society of engineers that were always hidden away in these exclusive offices that were designing the next generation. Almost every aircraft company that's been around for a couple of years will have that set up, so they don't have to listen to all the poo-pooing from all the other engineers about how this new thing won't work or why it won't work. So they get set aside in their own little world. Apple did that years ago for like the Macintosh, like they completely separated them from the rest of the company, and that's a normal thing to happen. But how do they do that on such an industrial company that's making large wind turbine blades? Do they do that, or is it the same engineers that are designing the 60 meter or designing the 108? How does that work internally?
I don't think there's such a big split, and I expect that the product development cycles are much faster for wind turbine blades than for aero. It's funny actually, because a wind turbine blade is, on the one hand, so much lower tech than aeroplane or something like that. So you might think, oh, that's less exciting. But on the other hand, you don't have to go through this. I mean, they have to be certified. You have to test them to make sure they're safe. But it's not nearly the same as testing a passenger aircraft is going to be safe. So on that side, it can be much more exciting because you can do something new and just try it, and not have to wait 10 years to get it approved. But no, I didn't see a really big split. They do silo off a lot projects, especially, a company that manufactures blades for a lot of different other companies. You obviously, you're not talking about one company's secrets to another one. So there's definitely, need to know basis. And I don't know a lot of the technical problems that the projects I wasn't working on. I don't know about them at all, even though I was in the company. But to answer your question about, it sounds really cool that you would be shielded from people telling you that your ideas aren't going to work. That would be nice. But I felt like in the industry, it was more like, we had this canteen at work, which is a really European thing to do, and I loved it. And so you'd talk to everybody at lunchtime, and it was much more like, I don't think people were often telling me, oh, that can't work. Sometimes, I mean, people would say, well, is that how long you've got to do that job? That's not nearly enough. But much more often it was like people were like, oh, I've got this crazy idea for how we're going to melt ice off blades now, so let me tell you all about it. And yeah, I had probably more out there ideas rather than people telling me that I was being too ambitious. So
that sounds like a YouTube channel, sort of, in the sense of, yeah, it sounds easy from the outside, but when you delve into the engineering, when you get down just below the surface a little bit, like, there's a lot of problems with that with that approach or this technique. I think that's what makes it interesting, is that you've been in those situations where you had to explain your way out, like, no, that's crazy, it won't work. Or, yeah, we can take a piece of that idea and yeah, it's useful, but in the big picture, it doesn't make any difference. I think that's really interesting about the sort of your YouTube approach and your engineering approach is it all has to work at the end of the day. And there's more to it than just the engineering design. There's all kinds of aspects, and unless you think about it as a system, as a very complex system, even a wind turbine is a very complex system, it may or may not be productive. It's a very interesting way to think about it, and I think it only occurs with engineers who have been around a little while, and been in your case, small companies and large companies, where you can see that difference. It does make a big difference, I think, in the way you think, in the way you approach problems.
One thing I really like about YouTube is that I can listen to all these ideas, because when I was working for a company, it was never about, would this idea work? Could it work? It was always, I have no time to think about that. Like, please go away with your idea, even if it is the most exciting thing. I just cannot spare a tiny portion of my brain to think about that. So, and that's kind of, I didn't like that. I found that sad at the time. I'm like, oh, I'm always shooting down people's cool, innovative ideas. And I didn't like that aspect. Sure. I mean, it's part of being a company that's got to make money. And I definitely agree that is great that wind energy does that, because otherwise we wouldn't, if it wasn't cheap, we wouldn't be at the point where, all of our COVID recovery economic plans also involve renewable energy. That couldn't have happened without this relentless drive to reduce costs. So I get that. But yeah, now I am getting approached by people with my consulting work. It's people that have really early stage technologies, and I can help figure out if it's going to work. So I still need to, make some judgments. I don't want to work on something that I think can't work. I won't work on something that violates the laws of thermodynamics. Like, I'll help someone figure out that it does, but I'm not going to. Beyond, I'll spend a day showing why it can never work. That's a good service, because then they don't spend, years and a lot of money. Yes. Or
applying for patents at things that just doesn't make any sense. You see that all the time, and you feel as an engineer who's been around a while, you just feel sad when you come across like, man, that was $10,000 that you did not need to spend. I could have told you that.
Actually, this is a really good time to say that people do not understand that getting granted a patent does not mean that your technology works. It doesn't mean that. It just means someone else hasn't done it before. Maybe because it doesn't work, it violates the laws of thermodynamics or whatever.
Yeah, like a wind turbine made out of banana peels. Like, probably hasn't been patented, probably for a good reason.
You know what? I bet there would be, though, because I know, like with composites, they're always trying to use biomaterials. So I know I've seen like sugarcane waste and stuff. So I reckon that's a good challenge.
Don't steal my idea, then, listeners. This is mine. It's my baby.
When you're working at a smaller company, did you have that feeling like at some point, this isn't going to go? Like, there's just no way this is going to continue just because of the nature of the thing. But there's a lot of enthusiasm.
Yeah. No, I worked on a lot of projects. I couldn't imagine a business case once they stopped getting government grants. And to me, that wasn't it didn't feel like I was having a real impact. So yeah, but I kind of like oscillate between like I've got to go to a really big company, have a lot of impact, and then I've got to go to a small company and do something exciting. And
right.
Yeah, I mean, I guess the dream would be to find the small company that then grew to have really make it with their product. But that's the thing about innovation is you don't know. You can never know ahead of time. Otherwise, if you knew it was going to work, then it's not innovation.
I think to your bigger point is that sometimes having other eyes that are sort of outside the industry that are kind of fresh eyes can really bring like new ideas to it. And I'll give you an example from my 2-year-old nephew. My sister calls me one morning and she goes, "Daniel, great idea. Ice cream salad." She's like, "Why is ice cream salad not a thing? Why does that not exist?" And we eventually, 10 minutes later, came to the idea that this was not a viable commercial product. However, it had maybe some potential at first. So like, well, maybe we have a food truck and people love salad and there could be like, anyway. But only a 2-year-old could think of ice cream salad, right? If you're in the ice cream industry, no one would even dream of that. So, but sometimes these outside, consultants, whether they're 2 years old or 50 years old, Ph.D. or still have someone else dress them, can sometimes bring a new perspective.
That actually reminds me a lot of. I did a lot of baking and cooking. That was part of what I think made me become an engineer. All those kind of experiments in the kitchen. And the first time that I was allowed to cook dinner for my family, I was making sausages. And I had the brainwave that sausages are delicious, chocolate is delicious, so I'm going to make chocolate chip sausages. And my mom was like, "Well, that's a fantastic idea. Why don't you try that for your sausages? But then, like, we'll make some normal ones as well, in case not everyone is ready for this, amazing innovation." And they were absolutely disgusting. Surprisingly, but yeah, I mean it's experimentation, and that's how you engineer. You try it. You have an idea, you try it, and it works or it doesn't. You learn something.
Well, so I want to shift back to some of the more specific work you were doing with LM. So you worked in blade heating systems. Obviously, we talked about the Texas incident here early in 2021 with a couple episodes here on the show. I mean, what was your take, having a lot of experience in that, what was your take with that whole debacle?
It was really funny because, that picture of the helicopter spraying water on a blade went around. It was all over Twitter and everyone saying, how ridiculous this is. I mean, so first of all, it wasn't in Texas, obviously. That was from a Swedish study. But the thing that I thought was the funniest is that I have used that image so many times in presentations to customers to illustrate exactly what kind of de-icing system you would use somewhere like Texas, where you have really infrequent icing. It's just, you would never install a heating system on a blade that you expect to use every 20 years or even every 5 years. You need to be losing at least 5% of your annual energy production to make it worthwhile, and more like 10% is a more comfortable level, because you add cost and you add a lot of complexity. So you're adding maintenance, you're adding something else that can go wrong, that's, I don't know. It's also funny that you could think that making your wind turbines, gold-plated for cold weather was going to do anything to protect your whole system security, because obviously this cold weather could have happened when there was also no wind, and the wind turbines would be off regardless of whether their blades are heated or not. Like, the system security needs to be thought of on a system level, not if you make every individual component able to withstand any kind of operating condition, you're going to end up with a really expensive system. So I think that's like an old versus new energy kind of thing. And it's something I've noticed coming into, because now I'm working a lot more with a clean energy transition as a whole, not just the wind part. But so I've come into it from renewable energy, no background in the energy system, and So I don't have, I'm like like the 2-year-old. I don't have all these ideas about how you do things, because it's obvious that the new energy system is going to look so different to the old one that I don't think it's even worth thinking about how we did things before, for the most part. But specifically related to Texas, I mean, it seems obvious to everyone not in the US that you need interconnectors, and that's how you avoid that happening again in the future. I mean, the US is a huge geographical place, and if you're also connecting up to Canada with all their hydro, you can really smooth out a lot of, I mean, there's never going to be some sort of minus 20 degree freeze across the whole of the US at once. So you've got some interconnectors that can handle cold temperatures.
Yeah, but it's Texas. They do what they want. They want their own grid. They're just going to push themselves off to sea because they're Texas.
I was talking to someone about an electric vehicle to grid project recently, and I thought how perfect that would be for Texas, because my impression is that they really like their independence. And what's more independent than having your own electric vehicle with a battery that, I mean, you can run your house for a couple of days off a battery. And I mean, it's the freeze. It was kind of not. I mean, it was predicted, but it wasn't, people didn't think it was enough to worry about like several years ahead of time, but everyone knew about it days ahead of time. They knew it was coming. So you had time to, make sure your vehicle was charged. I think vehicle to grid, that's a good solution for Texas.
It is. Well, with Tesla building a new factory in Austin, I know it sounds weird to think about it this way, but it's one of the thoughts I've had recently is like, well, there is going to be a gigantic Tesla factory there and probably a battery factory at some point. And Texas is going to become even more energy independent from the rest of the 49 other states because of that, because they will have this huge battery resource in the state. It will make a big difference.
Yeah, but I mean, that is a thing about, new energy versus the old, is it is a lot more distributed, and there's, huge events that are going to be as widespread. Like in Australia recently, we had an explosion in a big coal power plant. It's going to take a year to come back online. But I mean, that same sort of thing doesn't happen when you have wind turbines everywhere and, like a lot of distributed storage and stuff. So you do need to see the benefits as well as the challenges of, this changeover.
Yeah, that's a good point. There's a lot of anti-fragility in having 100 turbines that all generate a little bit of power compared to one big coal mine that could, unfortunately, which happened, blow up or completely go offline. So that's a good point. With that, I want to shift to offshore. So obviously, with your experience working on the structural components of blades and the heating systems, there's going to be so many offshore wind farms coming up. What are some of the challenges that engineers are going to be facing, getting these blades prepped for some new inhospitable, ocean environments?
So I think the initial problem was just the size of them. The blades are so big and it starts to make things more challenging. Like, if you have a root diameter of 2 meters and you can stand in it and, reach the sides, but when it's 5 meters, you can't do that anymore. So there's some really kind of mundane challenges that happen to be really big and require, in the technical innovations to solve them. Yeah, and then the logistics of getting them there. Everyone's building their factories right on the water's edge so that you can just chuck it on a ship and drive it straight to the wind farm. So those ones, I think they're probably, getting their head around that, and they're mostly solved. But I think the hardest thing is that maintenance is such a pain. It's such a pain. Like, I've never worked on an offshore wind farm, but one of my colleagues I was working closely with, he did a lot. And the days are so long, you get one boat or one helicopter that's going to drop workers off at every turbine, and then you wait until someone comes and picks you up again. So you might only have to do a 5-minute job up there, but it's going to take your whole day for, the person doing the work, the person that's there spotting them. And I don't know how many people are involved in a rescue team offshore, but you've probably got a team of 4 or so just even for 5 minutes of work. So that makes it really hard with new technologies. Things go wrong. And that's another reason why, it's really good to develop your technology in the most friendly location possible so that you can get in there and change things. I think that's probably the biggest challenge. And then, of course, just everything wears out so fast in salt air. Even stainless steel rusts. You've got to have higher grades of everything. Every electrical component has to probably be changed, or at least have a new certification. It's just very expensive.
How would icing be affected there when you get to the bigger blades and being in the water, salt water all the time as you get further and further north? What does that look like on the icing side?
So far there aren't a lot of offshore wind farms with icing. I don't actually know of any, but definitely like in Finland, they have some proposals for wind farms that are offshore but could definitely benefit from the icing, the de-icing. And I think it's the same problem but magnified. All your materials and everything have to be of a higher grade. Seals have to be better. But then the blade heating technology, it's not that mature. It's not at the point yet. It's not as mature as, the rest of the wind turbine, or a lot of the rest of the wind turbine technology. So it's not at the point where you just install it and then you never go there again for the next 20 or 30 years. There is maintenance involved, and it's just so much more expensive. So your business case, you need a lot more icing to pay for the, an extra trip out to every offshore wind turbine. It costs a lot of money, so you need to be making at least that amount back with your being able to operate through days when it would have been icy. So it's always economics.
So is the solution then probably is not to just operate them when it's really icy, just shut them down for that time period? Is that from a cost standpoint, an operation standpoint, is that the answer?
Yeah, and there's plenty of really smart people working with the operating systems to figure out what's the most profitable way to operate them. But so first of all, when there's just light icing, you can change the control system a little bit so that it will operate through some light icing. And then at the point where it's unsafe for the turbine, you need to shut it down before then. Because if it gets unbalanced, or if there's too much mass on the blades that it's not, the blade structure isn't designed for that, then you need to shut it down. But it's usually not a lot. There's some really heavy icing sites are in like Quebec and in northern Sweden and in Norway. It kind of gets better as you go from west to east in Europe. Those ones you can see up to like 20% of your annual energy production reduced from icing. But most places it's, like if you think about the Alps, for example, that's full of snow, and you would think all those turbines would need de-icing systems, but they generally don't actually, because it's a few days per year. It's really complicated, actually, because it's not just the temperature. It needs to be, like around 0 degrees Celsius is the worst, because that's when, there's moisture in the air, but it will freeze. So it's kind of complicated too.
So I want to transition a little bit to, I guess, the balance of technology versus, pushing the boundaries of technology versus optimizing what we already have. So there's a lot of very well proven, wind technology. Turbines are huge. Offshore is working, right? Do you think we still need to continue to push the envelope on tech, or do we really sort of need to start trying to just optimize and use better what we already have?
I think with wind, we really need to keep trying to expand it more. So, we have offshore, but we only have offshore for shallow water for now. So developing floating wind turbines is really going to open up a lot of other areas. So if you think about some countries, even Australia doesn't have a lot of really shallow water to put offshore wind turbines in like Europe does. Countries like Japan as well, they don't have a lot of ways that they can make renewable energy anywhere that's really densely populated. If they can get offshore, then, it makes so much energy. It's like huge amounts of energy that we can put into the grid. And the the best thing is that it's not correlated with solar, really, you know. So you can say, oh, solar is cheaper. You know, the levelized cost of energy, a cost per kilowatt hour is cheaper for solar, so we just only build solar. It's one over wind. But I mean, the solar, it all in one place, it all comes on together and all turns off together, whereas wind doesn't do that. So I mean, it's not like it's running all the time, but the good offshore sites practically are. You can get, you know, over 50% capacity factor now. So I think that we do really want to be able to have much more wind. That's going to make our energy transition much easier. But I do take your point. In general, I think people are really focused on new technology to get us out of problems. And if you know, like a lot of politicians and some other, you know, like important thinkers are saying, you know, we just need nuclear or to have a big breakthrough, or we you know, we've got hydrogen coming on now and that can do everything. So that's great. But the thing is that we have most of the technologies that we need to get most of the emissions reduction, and it matters how fast we do it. You know, if everyone's got these net zero by 2050 targets, it makes a big difference if we just emit at like normal up till 2050 and then drop. There's this, you know, whole chunk of carbon dioxide in there. If we get the electric vehicles happening, we get energy efficiency happening, we get all of those heat pumps instead of natural gas, where it's easiest to do that. You know, there's heaps of really huge chunks that we could take off right now that would cost very little. And then it doesn't matter as much if we, you know, take longer than 2050 even to get that last little bit. So, yeah, I think that in general people are way too focused on coming up with a new solution rather than using the ones that we've got. But the thing is, because these technologies are mature, but it doesn't mean that they'll happen on their own. You can't just, you know, transition your energy system away from, you know, coal power plants or nuclear. It's just, you know, all this base load that you've got to use to a really flexible, distributed, dynamic system. It doesn't. It's technically possible, and it will be economically beneficial, but it's not going to happen on its own with the markets that we've got, the regulations that we've got. We do need to do a lot of work, but it's easy and cheap compared to, you know, betting on I don't know, cold fusion or even green hydrogen for everything. You know, I think that we do need to start using what we've got.
Yeah. Well, you mentioned the levelized cost of energy. Can you speak a little more to that? Because I know that's something you're really interested in. I mean, what do people need to know about that, and how is that changing?
Yeah, so levelized cost of energy is the number one metric that I think most of us working in renewable energy over the last decade or so have been focused on. So how much does it cost to make 1 kilowatt hour of electricity from this particular source? So it includes everything from like how much does it cost to manufacture, to transport, to install, to rent the land, to maintain it. All of those things are kind of, like on the top of the equation. And then you divide all that by how many kilowatt hours it's going to make over its lifetime. So you get this one number of how expensive your energy is. And everyone's probably seen those charts of the LCOE just coming massively down, like dropping really rapidly for solar, not as rapidly for wind, but still, very, very nice cost reduction, or nice from the point of view of the consumer and not from the point of view of the manufacturer, I guess. So that's been the real focus of the last decade, and that's good. When we only have 10-20% variable renewables, you can have the cost is the most important thing. But now we get to the point where you see in the electricity markets, like if you watch what the wholesale price is, and California is a famous example, they've got their duck curve where the cost of electricity, it actually, it's lowest in the middle of the day when there's all this solar online, because, it all comes on together. There's heaps of it. It brings the price way down. But then as soon as the sun starts to set, you get this massive spike in price because, you've got a lot of cheap energy, but it's not when and where you need it. And so I think that when and where you need it part of the equation is going to become, obviously it's going to become more and more important as you get more variables in your system. So that's why everyone's so focused on energy storage now. And then other things like, well, less exciting things like interconnectors and demand flexibility and energy efficiency. All of those things make our problem much smaller. So I'm personally most excited by like demand flexibility. I'm really really excited by that, but it's not so sexy as as hydrogen or something.
See, this is the part I like about Rosie's YouTube channel, is because you don't think about those details in an energy distribution system, or especially electric grid, of all the fine details that really matter, like solar goes offline at about 6:30, but there's just a demand when everybody comes home at 6:30, and so it's not as valuable. Or how you connect and disconnect different parts of the grid at certain times, and what kind of chaos you create when you do those things. Those are really important. And those details get lost, right? Because we see...
We need Netflix more than ever with COVID. After 6:30, solar cannot supply
Got that right.
America with their Netflix.
That's exactly right.
Yeah.
You maybe run a Netflix off your car, and Tesla's got the answer for that, right? But yeah, that's the real part of this, which is in your day-to-day life, how much do you think about where your energy is coming from, and can you get it? And if you live in California, you start thinking about that a lot. If you don't live in California, you don't, right? And so having been out in California a lot recently, because my son was out there, you realize like, ooh, they're having blackouts, they're having brownouts, and that's a continual thing. And they're having huge, massive forest fires at the same time. So you start to think, wow, the grid, I really rely upon this electric grid. And if part of it goes offline, hey, I don't have refrigeration, I don't have air conditioning, I don't have lights, I can't cook. Those things become more and more important. And that's why I think when Rosie gets on the YouTube channel, starts and explains those details, it makes it real. It makes it real to the average person. I think that's what's really cool about it.
Well, and it's also, I think, hard for people to get access to someone with like the level of education and experience that you have on YouTube. Like YouTube feels very impromptu, but for someone to be able to ask an actual engineer who will actually respond to their comments is super rare and also really cool. Yeah. So I think you're doing a great service for people out there who are just, ice cream salad all day, and they want someone to just slap it out of their hands.
Say, sorry, Daniel.
Or maybe give them a gold star. You don't know.
Yeah.
So Rosie, as someone who's, in the industry, and you've got your consulting business, Pardalote, tell us about what you're doing and how companies can connect with you and what your mission is.
Yeah, thanks. So I started up an independent consulting company, and I'm working on energy technology development, basically focusing on two sides. On the one hand, if there's a company that has a technology that they want to develop, then I can help them figure out, a fast and cheap way to do that. And especially when it comes to the wind industry, avoid some of the traps, because, wind, it seems like it's really similar to, aero industry, but there's some really different, it's a really weird operating environment, let's just say it that way. If you put something in a wind turbine, and especially on the blade, there's some forces there that, it's not like normal components aren't designed for that. So you have to be aware of that when you're developing a technology. I do that help with the technology development, and then on the other hand, with companies that are investing in energy technologies. So whether it's a wind farm developer or just venture capital or any kind of investment company, helping them do due diligence. Is this technology feasible? What kind of milestones should they be hitting with their development to make sure that we're moving in the right direction? Banks want to feel sure that a technology is going to last, full lifetime before they will finance. And then what happens when there's problems with the technology? Oh, your blades have cracks in them, and are they being fixed in the way that that you think is like? Can you feel sure that these blades are being brought back up to the way that they should be? So that's basically the range of services that I'm doing.
So it sounds like you can be a good intermediary for companies as they try to solve and interpret some of their problems.
Yeah, that's it. And some of the technology companies that I'm working with are definitely like I feel some ownership for the technology too, because it's nice. That's the creative part of it for me, and probably the most exciting kind of engineering in a way is when you've got technology. It's an idea, could it work, and then you work with it and you start to feel like they're your children by the end once you've guided this poor little technology through all of the hazards. So I like that part of it too.
Well, can you give our listeners ways to follow up with you on the web? I know you have a website and you're active on LinkedIn. Obviously, we'll link to all of the the places you can follow up with Rosie. But what are the main channels that you've got? Yeah,
so YouTube is Engineering with Rosie. And then I'm on LinkedIn a lot, just Rosemary Barnes, and my consulting website is pardaloteconsulting.com.
Awesome. So definitely check out the show notes, whether you're on iTunes, Spotify, Stitcher, or on YouTube. We'll have links where you can click right through and get in touch with Rosie. So Rosie, thanks again for coming on the show. It was a great conversation, and we might be knocking on your door and we have more questions that we can't answer on the show down the road.
Yeah, I would love to be invited back. So thanks a lot for having me. It's been really fun.
All right. Well, that's going to do it for our episode of the Uptime Wind Energy Podcast. Be sure to check out the description, whether you're on iTunes, YouTube, Spotify, wherever. And be sure to subscribe to the show, share it with a friend, and we will see you here next time on the Uptime Wind Energy Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.